Because of that one post, I lost 25,000 TikTok followers, and it's insane. I take it back if I could. All right, so here we are. Cool. I want to find this distance. Not the distance, I'm sorry. I want to find the midpoint of that without measuring a distance.
I'm not
Okay. Nope, if it's a straight edge, I'm good with that. Cool.
I don't know how I lost that already. I feel like it's been like 2 days.
Yep, welcome to my life, man. Okay, I'm going to let you guys play around with this 60 seconds. 60 seconds is it, and then we're going to see if we can find a way to make it. Talk it out. You're going to probably be wrong, which is a good thing in math. I want you to be wrong. I want to be wrong. Cool. Come up with any ideas, good or bad. Let's check this out. We have, right now, there's a distance drawn on the screen, right? Now, here's what I want to get in the habit of doing. This distance that we see up here from A to B, it has different components. That word sounds really fancy. All that means is that to get from A to B, you could walk a diagonal line, right? Or you could walk a horizontal line followed by a vertical line. Everybody on board with that? So, for example, if I want to get from here to here in the x direction, which is just this. What? I'm going to make that bracket a little nicer. How far do I need to walk in the x direction? 6x. And then similarly, if I'm over here, how far do I need to walk in the y direction? 6 in the y direction as well. Everybody okay with that basic idea? We split it into two components, the horizontal x and the vertical y. Now, here's where what I had said a minute ago and accidentally gave you guys the answer. Let's just treat them each individually. So, in only the x's, how do you find the midpoint between that x value and that x value? So, I'm going to say x mid, and we'll just look at this. I think we can just do x1 plus x2, and then do what to it? Divided by 2. Now, I need your help, though, because I don't see x1 and x2 written anywhere up here. What are they? What's the first x value? 0 right here. Plus, what's the second one? 0 plus. So, if you're looking at this, you may be thinking y is 0, but x and x. Where's the middle of the x's? 3. So I'm just going to mark it right here for now. Notice I didn't put a point. Everybody okay with doing it in the x direction? In the y direction, is it going to really be any different? Okay, so the y midpoint. Now, coincidentally, we use 6, 6, so it's going to be the exact same operation, right? So I'm just going to say the y midpoint would be y1 plus y2 over 2. And much like before, except we're just flipped. What's the y value? Oh, no, we're not flipped. We're exactly the same. 0 plus 6 over what? 2, and I get 3 on both of these, yeah? So check it out. Here was the x direction. Here is the y direction. Doing them each individually, is that any harder than what we did the other day? Let's just put them together. If we put this x and this y together, it forms an ordered pair right here. What did we just identify? The midpoint. We don't need to think about the diagonal line. Think about the parts of it. There's a horizontal component or part. There's a vertical component and part. From this, we can work out a sweet and super easy to use formula. So here we go. Midpoint formula. I'm going to put a star on this because this is going to be an important one. Okay. For this, we can be really, really, really formal or not. I don't know how much you guys are into the math. Do you want to be formal mathematics, or do you just want the concept and easy to use for us here? Everybody's obviously going to take the second one. Why would I even ask? Yep. Super formal. All right. We're going to say the midpoint. Between, and we're going to write this in general terms, okay? We're going to say our first point is A, and its ordered pair is x1, comma, y1. And B, shot in the dark, x2, comma, y2 is, and I always call it point M unless it's taken, M for midpoint. We just have to shove these guys together. Find the x's midpoint by adding and dividing by 2. Find the y midpoint by adding and dividing by 2. This is what I was asking about at the start of class. X1 plus Y1. Whoop, just kidding. What did I do wrong? What should go there in the x direction? X1 plus what? X2. I wrote Y for some reason. That gets divided by 2. And we use a comma. And then we just have the other half of it. Y1 plus Y2 divided by 2. Diagonal lines, mathematically, it seems like it's going to be harder. Doesn't have to be. Cool. I want to try one more extension problem, and I want to see how you guys set it up. There is a super easy way to do this problem, and then another way is using the formula. Cool. Before we move on, any questions that you guys have about this? Feels all right? Okay, so here's my challenge for you. I'm going to talk like a caveman, so we don't have to write a whole paragraph. M, at what point, Lily?
5, 3.
Okay, so M lives at 5, 3, and we're told that this point M at 5, 3 is the midpoint of segment AB with A at which point, Carson?
2, 1.
2, 1. Okay. I want you guys to help me find B. I want to find the other endpoint. So notice, we've switched it. Instead of saying, here's the endpoint, let's find a midpoint. I said, here's a midpoint and an endpoint. Let's find the other endpoint. Same math is happening, we're just rearranging it. Okay, I'm going to give you guys like 30 seconds. Quick brainstorming, not to write anything down. I'm going to call on somebody random at 30 seconds, and we're going to start this problem. If you're not ready to be randomly called on, I would talk with people so you have an answer of some sort. Excuse me.
Okay, so midpoint is at 5. A is at 2. So what I'm thinking is you just double the midpoint.
But if we double it, only goes to 4.1.
What? If you double it, it becomes 10.6.
You can
No, if we double it, because if A is 3.1.
All right, so here I am struggling, but the good news. Let me get your list out. Is Vincent's gonna help. I don't know what to do, Vincent, and you might not know what to do, but you're gonna give me something to do, whether it's the right thing or not. What do you think? Okay, I need some assistance, number 6.
So we would write it down.
Deal. Done. Look at me. I'm good. If somebody comes and says, Holloway, will you help me? What's the first thing I'm going to tell you every time? Do you have it drawn?
I do.
Do you really?
Yeah.
Good on you. Now, I'm going to sketch mine as well. Do you have it drawn, Raylene? No, you're good. I told you not to write anything. That's okay. Okay, let's draw it. Let's see if this helps make sense. So here we go. I'm going to use here, and I'm going to look at this. I assume that it's all over here. So I don't have to be crazy good with this. Everybody believe if I say this is A at 2, 1, it is?
Yes.
Okay, and then M is at 5, 3. I don't know, here. And then B looks like it'd be somewhere over here. Are you guys cool with this? Okay, so we have this part given, but we're trying to find from M to B. Now, there are 2 ways to do this. We can get real mathy with it and do like the analysis, the algebra, but it's not the only way. Okay, let's do the mathy way first, and then, because the other one to write down isn't nice, but we'll talk it out. So help me out. I know that there is a midpoint formula, right? And do we have to do it as like a whole diagonal segment, or can we just do it with x's and just with y's? We can split it up into components, right? Do you guys know the x coordinate of the midpoint? 5. Now I know that to get this number, we do what to the endpoint's x coordinates?
X1 plus.
So it'd be, in this case, it'd be 2 plus, do we know the other x? I'll just gonna put x. And then I divide by 2, right? Okay, this is the x direction. Can we do the same thing in the y direction? Raylene, what's the y coordinate of the midpoint? So can you tell me which point up there on this line is the midpoint, or on this segment rather? A, M, or B? And which one's y here, 5 or 3? So I'm going to ask the question again, you're going to give me the same answer. What's the y coordinate of the midpoint? 3. You got it. Okay. 3, here's the y one, equals, do we know either of the other endpoints' y values? Ah, that one's 1, right? Okay. 1 plus, do we know the other one?
No.
So what should we put? I'm not going to put x because we have to put some. Right, see, picking up what I'm laying down. Okay, welcome to algebra. Together? One of them together? All right, let's do the x's together. Who loves fractions? Who thinks, okay, me too, just for the record. Who thinks a problem's easier, even if you like them, if there aren't fractions? Are problems easier without fractions? So,
They could have hard.
I think so. The good news for this is that I think you guys can tell me this real quick. What am I dividing by that makes this ugly? 2. How do you undo it so it's not ugly? Let's multiply each side of this equation by 2. Okay. And I'm going to use this purple to annotate. Now, I cheat with it, just so you know. If I'm doing it to everything, oftentimes I'll do it like this, with the understanding that Mr. Russell or Ms. Jarvis probably did it like this. I just like to put it around everything and say, look, I'm going to do it. Okay, so over here, 2 times 5 gives me, yep, okay, equals, when I do the 2 on this side, anything special happen? What happens when I multiply by 2 and divide by 2?
Cancel.
I'll take it. What remains on the right side of this equation then? 2 plus, not plus 2x, because,
they're getting divided.
yep. Okay, I'm 1 step away. Subtract 2 from each side of the equal. And we get, I'm going to switch it around as well. Gosh, with the what property allows me to go from, I'm going to write it like this. 8 equals x is what we'll get. What property allows me to rewrite it like this?
Symmetric.
This is the symmetric property. Okay, so we just got x as this value right here. Right now we have this. I want you guys to algebra through, get me the y value. If you don't have to show any work, that's okay. If you have to show your work to avoid mistake, also okay. The only time it's not okay is if you think you don't have to show your work and you get it wrong in a quiz or a test, you get 0 of your partial credit. Don't just shut it out because I think you probably have the answer. So here's my question for you. If you were done, could you do this without any of the math showing? Like, is there another approach that you could do this mentally without having to do all these calculations? Love it. So same question to you. How could we do this without doing all this math right here? Good. I agree with it. Love it. We get the same thing. How could we do it without doing all this math?
No, go back.
I'll do this.
Wrote this one for gift.
Is he here today?
Let's see what she accepted.
He didn't.
Love it. Okay, so check it out. I'm about to blow your guys' minds. I like the math idea. This is nice, especially if we have the drawing here, or if you don't want the drawing. I'm gonna do the same thing here. 2 times 3 is 6. They're gone. I get 1 plus y. I get 5 is equal to y, or y is equal to 5. And I think you guys just came up with the same thing. Okay, your ability to do the algebra is there. Awesome. I need that. Love to see it. Here's what I want you to do on a test, on a quiz. This is a better way to do it. But check this out. The midpoint, M, is half the way across in the x and half the way across in the y, yeah? So I think that as long as this picture's in front of us, we can probably just reason it out. To get from one M point to M, only in the x's, how far did I step to get halfway? 2 to 5, I had to take 3 steps. Is everybody cool with that? And that's halfway. So how many more steps on the other side? 3. If I do 5 plus 3, what do I get? Oh, okay. Well, to get from A to B, how many steps in the y direction do I have? Or sorry, A to the midpoint. How many steps up? 2. So halfway was 2 up. So the other halfway is going to be how far up? What's 2 up from 3? Hey, we got the exact same answer by drawing it and seeing it. You can also count them out as long as you just count in your components, meaning count in just the x, count in just the y. Cool, cool. Everybody give me some sort of indication. Thumbs up says I'm killing it. These are easy. This is a harder problem just now, but I'm doing good. I'm doing really poorly. Give me some sort of indication where you're at. Okay, so we will get more practice. There's only one more big idea hiding behind here, though. We talked about midpoint. We're going to talk about distance as well. Now, I don't know if I've ever specified this. I'm not a big memorized teacher. Like, I don't like the idea of having to memorize stuff. Any quiz, any test, you guys will be okay to use note cards that you'll make yourselves, so you don't have to memorize stuff. Every formula, every theorem, all that will be on a note card if you put it on there. Ashley?
We can't use the whole.
No, we cannot use the whole notebook. Good try, worth it. Sweet. All right, let's talk a little bit about distance. Now, when we do distance, we looked at this the other day, and I'm not trying to talk really loud here to you, other person. When we did it the other day, we did the difference, and we took the absolute value. That was it. We're going to do something awesome today. I want you to finish this statement for me, just with whatever natural. A squared plus b squared is?
C squared.
What is that? Okay, so I'm going to make everybody say that one more time, because I'm crazy. Pythagorean. There's no M. Pythagorean is what people always say. The Pythagorean theorem. It works for what sort of triangle?
A right.
A right
Right
triangle. And how would you actually word it? A squared plus b squared equals c squared. What are A and B and C?
One angle plus another angle equals hypotenuse.
So C is the hypotenuse.
Oh, yeah.
So what's the hypotenuse of a right triangle? What does that mean? The longest. Yeah, it's opposite from the 90 degrees. So if you take the length of the hypotenuse and you square it, it is equal to the other two sides squared and added. Okay, the square of the legs of a right triangle is equal to the square of the hypotenuse of the same right triangle. It's how that reads. It's ugly, it's a mouthful. But check it out. You think you guys could do a Pythagorean theorem? So prove it. I want you to find me the third side of this triangle real quick, okay? I'm going to give you the two short sides. This is off on the side, really tiny. I want you to find me the third side of this triangle. I want you to find me this. I want to see if you guys can indeed Pythagorean it up. I'll give you a moment. What to do? Right?
C squared 3.
Okay, I'll call that C first. And then you said square 3
Wait, why would you call that?
Square 4.
plus 4 squared equals,
C squared.
okay, what's 3 squared?
9, 16.
Still equal to C squared. So 25 is equal to C squared. Are we done?
No, you have to square that.
How do you undo a square? You take the square root. C is what?
5.
5. You may remember 3, 4, 5 right triangles exist. You might not have. I'll tell you, when we get to the Pythagorean theorem section, it will be beneficial to remember it. All right, we're going to do all this. We're going to derive a formula today. To derive something in math means to see where it comes from. So instead of me just saying, oh, here's the distance formula, use it, that's fine. A lot of teachers do it that way. But I think it's more valuable to say, let's find this formula and then we'll use it. Because if you know where it comes from, you don't have to memorize it. You just have to either think back to when you did it. I don't know. You guys might not agree with that. All right. Here we go. The distance, and I'm actually going to say distance formula. Okay. If it's a horizontal or vertical line, super easy. Because you just subtract it and take the absolute value. Like, that's all you do. Let's get a little crazy here, though. We're going to work all in general, which means we're doing this for every problem ever using no real numbers. So let's say that we have A here, and we have no idea where that point is, yeah? And I want you to pay really careful attention to where I'm putting my letters. I'm doing it intentionally. There's point A at x1, comma y1. Could be 1, 2, like, don't care what the numbers are. It's just some ordered pair. I'm going to put B all the way over here, just like we did the last time. Again, notice where I'm writing my letters, because I'm going to add some stuff to this picture. If A was x sub 1, y sub 1, Camille, what would B be written as? Love it. Everybody agree with that? X sub 2 and y sub 2. All right. If I want to find this distance, why did I ask you about the Pythagorean theorem? I didn't draw a right triangle. What is this guy doing?
You could make a right triangle by just drawing a vertical line. I guess I don't really have
Okay,
a vertical line in the.
I'm going to do what Ray is suggesting. Ray is saying he could drop a line straight down. Now, it could drop down forever, but I stopped here. From this point, could I drop a line straight over? Will these two meet eventually? And if one's vertical and one's horizontal, they're a right angle. Everybody okay with this? All right, here's the first challenge part. We got a new ordered pair here. I'm not going to name it, but I need your guys' help. I'm not going to call it a letter, but I do want the coordinates. Could we write that ordered pair? Other than x3, y3, because I think that we don't even need a third value. If I'm here and I drop straight down, am I still at x2, whatever it was? Am I still at x2? Am I still at x2 right here? So what x value should this ordered pair have? x2 and y1. For the same thing, I'm at y1 anywhere when along this horizontal line, same y value. Okay, this is pretty abstract right now because we didn't use any real numbers. Did I lose anybody? If I was at 5 and I didn't go up, I'm still at 5. That's all that I'm saying here. All right, so now let's assign this idea of the Pythagorean theorem. I'm going to call this C right now because that's my, gosh, what do you call that side of the triangle? The hypotenuse. The other two, they're not the sides. Anybody know the word? They're the legs. Love it. Okay, so we have this leg, which I'll just label A for now, and I have this leg, B. In the Philippines, anybody who's studied or abroad anywhere at a different school, is it always A squared plus B squared equals C squared? If you go to England, they read it as X squared plus Y squared is Z squared instead. Z. Which is how, I'm in favor of Z instead of Z, because E, B, P, there's confusion. All right, help me out here. Pythagorean theorem. Okay. A squared plus B squared equals C squared. We have that. If you don't want to jot this down, I'm just going to start here because we are deriving this formula. Now, you will learn here pretty quick. What do you think this is a crazy word. What do you think this is my shorthand for? The Pythagorean theorem, I just call Pytheorem when I write it down because I'm lazy. Okay. Let's apply it in this context, though. How do we find this distance? Did the y's change at all?
Y or x2 minus, or wait, is that y?
x2.
X2 minus X1.
Could I do x2 minus x1 and that would give me this distance? Now, here's the thing. Your book, if you walk through it, they do something similar. They use absolute values. I'm not going to. I'm going to ask you why I don't bother writing it because it makes it look so ugly. But I do think that A is exactly just x2 minus x1. If you take the difference here, you get this distance. Everybody cool with that? That's A. Plus, what would B turn into?
Y2 minus Y1.
If you take this distance, it's just the difference between those y values. Vincent, are you cool if we call this y sub 2 minus y sub 1 and we square it? Okay. If we just plug directly into the Pythagorean theorem, Raylene, what is it still equal to? We don't know the numbers. I replaced A and B. Did we plug anything in for C? So what should I write on this side still? Yeah. We're just substituting in. Questions here. This is where, if you're going to get messed up, this is where it's going to happen. Okay. Well, if I wanted to solve it for C instead, how do I do that? Because I solved it for C squared right now. Gosh, if only there were a way to undo a square. Oh, that's a good idea. Okay, I'm going to do two things. I'm going to use symmetry because I'm going to write C first, but I'm going to take the square root of both sides. I'll do this. The square root of C squared is C. The other side is ugly. I'm just going to keep it as it is right now. Have we solved it for C at this point? Did I lose anybody in the algebra to get here? Or let me rephrase that. Where did I lose you in this algebra to get here? Ashley.
You know there's x2. Oh, no, I mean, I get it. There's only, because there's two b's on top. So never
There's two B. Oh, lowercase and uppercase. Yep. Pretty common that we'll see that. Okay, here's my question. For this, we're pretty much done, just so you guys know. If I had done this, and I don't want you to write it, I just want us to think about it. I only did x2 minus x1 because somebody said it. Could I do this?
Yes, if you were using absolute value.
So I don't even need the absolute value. What happens, so like one of these directions, this will be negative, right? But check it out. Let's say it was negative 2. When you square it, what do you get? What's negative 2 squared? 4. What if it was positive 2 when we squared it? It's still 4. I don't use the absolute value symbols. Your book puts them right here. But I'm going to be like, we'll see this again. I'm sure of it. And you'll hear me say it either this class or another class. If we're going to square it, do I care if it's positive or negative? No, not even a little bit. Okay, so check this out. All we have to do is one Pythagorean theorem and we're there. Instead of calling this C, all I would do is I would just add this, and here's our distance formula. This is how you find the distance between any 2 points on the coordinate plane. Just the Pythagorean theorem. It looks ugly, but it's no different than just using a squared plus b squared, except there's one little step forward. Let's do some practice with this. My dogs spilled a cup of coffee on my notes, and I had to rip off like 10 pages, and I'm still angry about it. Cool. Let's do an example. Oh my bold. I'm going to do it right here so that you guys can see it. And let's find distance. Notice, if I just write AB like this, what am I asking for? What about it? Is it a segment or is it a measure of a segment? It's the measure. What would I have above it if it was a segment itself? Not a line. I call it a bar, but a segment would be fine. Cool. All right. Here we go. You want a hard one? Okay. Challenging one it is. I want A to be the point, I don't know, 3, 1. And B is the point negative 3, 2. I want to find the distance AB. We're going to do this one together, I think. Well, doesn't really matter what I call x1 and y1 or x2 and y2. If you need to, especially when we're starting, I think it's a good idea to do this. x1 comma y1, x2 comma y2. This is not a requirement, but if you struggle to plug stuff in from a formula, there are my x's and y's. Raylene, even with glasses, do you struggle to see from there? Okay, so I'm going to make you uncomfortable and comfortable at the same time. So this is the uncomfortable part because you're going to be sitting at the front. This is the comfortable part because you can use the super comfortable chair if you would like. I'm going to leave it up to you. You don't have to move. But if you want to be able to see and be comfortable, there's a whole big workspace here for you. All right. So let's find it. Let's just knock in. What color is my solution this time? Is that pink? Can everybody see this?
Yes, 100%. It's more like it.
All right, so check it out. We're just gonna plug and chug. This is not gonna feel, it'll feel like math, but it won't feel like fun math in my opinion. We just gotta plug stuff in and see what it is. Andrew, can you give me x2 minus x1? What numbers would that be?
2 minus x1,
Mhm.
negative 3 and 3.
So negative 3 minus 3. Notice I put the parentheses around it and I square it. Plus, Carson, what's the y's?
2 and 1.
2 minus 1, and I square it, right? Okay, you guys have seen square root stuff before, very clearly. I don't think you remember all the properties perfectly, so we're going to be really, really careful with this. First thing, little step by step. If you're going to use a calculator, parentheses will be the death of you. I guarantee somebody's going to get the wrong answer if you type this into a calculator. Let's do it first by hand, and then if you want to grab a calculator, we can check. All right, here we go. Let's clean up this first set of parentheses. What's negative 3 minus 3? Negative 6. If it were positive 3 minus 3, but because they're both negative, we're at negative 6. Plus, what's 2 minus 1? 1. Notice the parentheses that I'm being crazy about. Now, on your calculator, and I haven't checked you guys out calculators, correct? Okay. Do you think you could get the right answer in your calculator? Okay, do me a favor. Go back there and grab one. And I'm going to pause this, so if anybody's watching this again, I want, if we keep going, becomes, what's negative 6 squared? 36 plus 1. Now, just a quick check. Is this 7? Because I know the square root of 36 and I know the square root of 1. No, you cannot simplify down like that. Here's what I would keep on my answer sheet. I'm going to say units because I don't know what they are. I would also be okay with, although I like it less, somebody read me the number you got? 6.08. Okay, notice, check this out. I'm going to make a mistake. I want you guys to tell me why I'm mistaken. And I'll wait till everybody's eyes are up. And you keep writing, like don't rush to do this. Okay, 6.08 I'm okay with. I think I'm trusting your guys' value. Why the second I do this, I'll do it obnoxiously. Why am I wrong?
But it's not equal to.
It's not equal to. The second you say 6.08, what did you have to do?
Just put that weird dash line.
Ooh, the weird wiggly equals, meaning what? Approximately. If you're going to use your calculator, which obviously I don't care if you use your calculator from time to time. In fact, I will give you some calculators eventually. Approximately, get it? I would stop here. This is my preferred answer. Sweet. Should we do another one like that, or you feel okay? Okay, here's the deal. We'll split the difference. I want you to do another one, but it's going to be on your homework. Cool. So let me see what the homework is today. Man, I don't know if I caught the stupid cold that everybody had last week and I have like a sinus ear thing, or if I've had my headphones on way too loud this morning, but my right ear feels like I have been at a concert and it's just ringing and like deaf and it won't stop.
So we got homework today?
You get homework, that is correct. One thing that I want you guys to highlight here, because you're going to use your books in a minute anyway, go to page 24. And I'll write the homework here, but I'll give you a second. On page 24, that's the left side of your text. At the very top of every section, this is so handy. Do you guys see where it says concept summary? This is like the main ideas from this section. So if you're ever wondering about like making a note card and stuff, there's what I would put from this section on my note card if I were you. It has it for you every time. Okay. Your homework, this is 1.3. You will find it on page 25. Then I want to remind you guys, in class when we check this, which ones shouldn't we really have to check them all for? The odds, because I'm going to give you the answers. I'm going to give you some evens, but the odds, I do want you to take advantage of that solutions or the answers. So homework 1.3, page 25, you get problems 9, 10, we'll have to check together. I like 13. I do like 13. And then I want us to do 15 through 15 through 25 odd.
Could just
We could do all of them.
13 through 25 odd.
You know, in hindsight, that would have been, or 9 through 25 odd, skip 11, add 10. All right. Okay, other thing. This one chapter and this one chapter only. There are, well, maybe not this part. There's 8 sections in this chapter. What are we going to do halfway through every time? Quiz. And I'm going to try to do better about doing weekly quizzes. In whatever way we go with it, after we finish 1.4, there will be a quiz. For this time and this time only, we're going to do an open note quiz. This one time, Ashley, I got you. Open note team quiz for the very first one, just so you guys can all see what my math quizzes look like. Because you've seen my science ones. I like math more than I like science. I don't know. Cool. Do it to it. You got 7 or 8 minutes. Remember at the top of your page, if my name were Andrew. Here it is. What else do I need?
Date.
I don't care about the date, really. I want the third geom, and I'm good with this. Cool. Top left. Don't write Andrew. Write your name. You can write Andrew. Andrew. Okay. Cool. And I'm going to show you the new song that I cannot get out of my head, and it's the one that I'm going to be singing at the open mic night this weekend. At least one of them. Me and Marquez are going to play together. Not her.
Would